Bonjour, monsieur.
Bonjour, bonjour. Hi everyone, so any question before we start?
Bon matin, monsieur.
Bon matin.
Good morning, Professor.
Good morning, Julio. I think that was you, not sure. Too many screens. Okay, people connecting, let's just wait maybe 30 seconds. We can start.
Good morning.
Good morning. Okay, so why don't we start? So if you don't mind, I'd like to finish the small example I was going through last time. I know this might be brutal to start the day with some math, but that's the way things are. Okay, but now I have a bit more time to explain what's going on. So for people who are not too familiar, this is what we call a function. So we're saying that QS, so I'm going to write more stuff here. QS is quantity supply. And QD is quantity demanded, right? And these are function of what? Of price. And that's how you write it. QS with parenthesis P means that QS is a function of the parenthesis. How is it a function? Well, because as we've just seen, the higher the price, then the more producers want to supply some good. So that's why we have QS of P, which is equal to here a positive function of price. Here I just said it's going to be the easiest function possible, so P itself. And this is how you express it.
Sir,
yes, there's Justin.
yeah, wouldn't the like quote unquote x-axis be P if not and not Q?
Okay, yeah. So this is due to a folk named Alfred Marshall, who's a famous economist at the start of the 20th century, who decided that it was easier to express economic model like this. So that's why in the slides, you always see a graph with P here and Q here. But it's true that so for people who have had some mathematics classes, then you're used to having the quote unquote independent variable. So X here and the dependent variable. So the variable that changes as response to X under a vertical axis. So that's exactly with this in mind that I expressed it in this form. So this is supply and demand, and this would be inverse demand, inverse supply. Because here what you're saying is the price on the market for producers to want to sell a quantity Q is equal to Q. And this is, so it would be PS of Q. And this would be the price that the consumers would be ready to pay if the market quantity is Q, would be this quantity 10 minus Q. But you realize that to get QS of P equal P and PS of Q equal Q, I just have to reverse Q and P and I get the same thing. And this, I just isolate P on that side and I get PD equal 10 minus Q. So that's, if you are still confused, all I can say is, yeah, you're going to learn more about all these math manipulations later. There is an example in the book, so I went and see what the example was doing, and they are using this there. Thing is, I wanted to make your life easier by showing the graph as we were showing in the class, but maybe it's confusing some people. So yeah, take it if it helps you. Don't look at it. It doesn't if it doesn't help you. Now the only thing I want to talk about is from this mathematical expression of supply and demand. How do I find the market equilibrium? How do I find this point here? Somebody knows?
You put the two equations equal.
Yes. So market equilibrium is some value Q star, for instance, such that QS of and some value P star. So we write Q star and P star to signify that it's what we're after. And it's such that QS of P star equals QD of P star. So quantity supplied at the market equilibrium price is equal to the quantity demanded at market equilibrium price. So there are no excess demand, no excess supply. So if I do that, I get that. So it has to be that P. So I get it from here, has to be equal to 10 minus P star. And then what I can do is add P on both sides to get rid of this P here, and I get 2P star equal 10, or P star equal 5. So that's my market equilibrium.
Do you have like to use 10, like is it 10 for this example, or like we have like 10 is like the relation?
Oh yeah, in the world, all markets, it's always 10. No, I'm just kidding. It's just my example. So I could have used another number. This is just in the textbook, they have, I think, 3P here or something. So they have different numbers. How do you know what the real thing is? Well,
Right.
you don't. It's
I think-
difficult.
I think the supply equation is like the inverse of the demand equation, right?
Not exactly the inverse, because here you have a 10 and you don't have anything there. But it's true that the sign is different. You have a minus sign in front of the P, and here you have a plus sign, +1 in front of the P. So this shows that higher the price, then the more producers want to supply, and higher the price, then the less consumers want to buy a good. Yeah, and then how do I find what is Q star? Somebody knows?
You just do one of the equations to find Q from P star.
Yeah, exactly. So I have P star here. I just substitute it here or here, for instance. So I can, let's say I use this one. So I know that QD of P star is equal to 10 minus P star. So I can write just Q star will be equal to 10 minus 5. So it's going to be equal to 5. And now I have my market equilibrium, which is 5, 5. And I can just write it.
I have a question.
Yeah, go ahead.
For the formulas that you have used to find out the P star and the Q star, since it has the equilibrium, can we use the other formula, like the one with the right hand?
These two?
Yeah.
Yes, you can do exactly the same. You would get Q equals 10 minus Q. So 2Q equals 10. So I can do it quickly.
Okay.
Yeah.
So
if you do,
we can use the two. You can choose which one to start with to find out the variables.
yes, exactly, because they represent exactly the same equation. So
Thanks.
oh, how do I get rid of this? Okay, good. Yeah. So here I have 5 and I have 5. This is Q star, P star. So that's how you solve a numerical example. I don't know whether there are numerical examples in the exercises you're going to get on my lab. So, but you know, to make you ready for anything, I wanted to make one. If it's still unclear to you and you have a question, come to office hours, ask me. I'm there for that. All right. So let us
I
start.
have a question.
Yeah, go ahead.
Can we figure it out from the graph without
Yes.
moving?
Yes, as long as your graph is very precise. Because
Okay.
if I drew something that's kind of okay but not so much, and maybe it looks like the equilibrium is here, or if you use the equations, then you know for sure you have the right answer.
Oh yeah.
Other questions related to that?
I do have one question. It's not necessarily about this. Is that okay? So for the opportunity costs, I was kind of confused when doing the homework. If like, say the P was at 5 instead, would that mean that the opportunity cost is 5 of P, or?
Okay, this is market equilibrium, so it's completely different. So opportunity cost has to do, well, everything is underlying everything. So, but yeah, don't get confused here. It's not one good against another good. It's price against quantity.
Okay.
So
But say it was like good, say it was like penguins versus like something else, I don't know, Q. And then it was at 5 instead of 10. Would the opportunity cost of the penguins be 1/2, or would it be 5?
yeah, I would have to make an example with opportunity. So why don't you come to office hours and ask, because yeah, that's something we've seen in the lecture 1 and we have to move on.
Okay.
So I can totally clear out any questions you have with that.
I have a quick question.
Yeah.
Are you able to rewrite a few of these things in terms of X and Y just to clear up any like confusion that I have? Because what I'm kind of understanding right now is that like, is X a function of Y in this? Or like,
yeah, so I would use these instead. And you would just, so now I'm going to do that, but please don't do that. So X and Y are just placeholders. They don't represent anything, but yeah. So it would be Y equals X. So that's the supply. And here you have. So this would be Y.
Professor, I have a question.
X. Yeah.
Is it possible to find the equilibrium without drawing the graph? Can we just use the?
Okay. Yeah, of course. Yes, sure. Yeah, this is just to show you that what I'm doing here means something in terms of the graphs we've seen before. But yeah, here I just did it by myself. I didn't use this. Right, so moving on.
Yeah, that makes sense. Thank you. I don't know why my confusion. I just needed to see that to understand.
No, so that's all right. So if we're used to something, some notation, then it's like using an old pair of socks. Oh, okay, now I'm at home. I know what I'm doing. But yeah, so in Russia, they say sometimes that they flip X and Y just to confuse students. So we're not going to do that here, but yeah, get used to having your mind flipped around all the time. That's how economics works. All right. So back to the now new concept, elasticity. Chapter 4. Yeah. All right. Okay. So elasticity, what is it? Why do we need it? Why do we introduce some new word to torment you? Well, we use it just because if I wanted to say something like, oh, if the market price goes up by $1, then the demand for for shoes in Canada would go up by go down by 10,000. What does that mean exactly? Well, how do you compare this to Canada and France and the US? They are totally different markets. So it doesn't tell us a lot. It tells us about how many people are buying shoes maybe, but what we want to express is some more objective measure of how people react to stuff. So we use elasticity instead, because that's a way to get rid of scale, get rid of units. It's something that allows us to really describe behavior. You're going to understand pretty quickly what we mean by that. Okay, so learning objectives. So we're going to show you how you compute it, explain to you how it is related to demand and supply, or what determines demand elasticity, supply elasticity, cross elasticities too. So that's fun. We're going to get into substitute complements, all this kind of stuff. All right. So what do we mean when we say that let's start with demand. Some demand is elastic. What we mean is people react a lot to a change in price. So if you think about it, if you think of an elastic, then if your elastic is short and stiff, then it means that people don't react a lot. But if your elastic can stretch very long, then it means that, okay, people have a lot of leeway to react to something in life. So that's intuitively how you should think about it. So what kind of good would be elastic? It always depends on the context, but one example I like to give is, well, maybe somebody has an example in mind already, if you have already heard that term. Otherwise, I can give one.
So, for example, instead of like buying the actual whole price of a phone, there is like contract prices, where like you pay every month.
Oh yeah, so you can so you're not stuck into a contract. Yeah, that would work in the sense that if then there's a change, if your operator says, okay, my price doubles, then you can say, okay, whatever, I change my contract and I don't have strings attached. In that sense, yes. So, but let me give a more simple example. So, for instance, Coke or Coca-Cola versus Pepsi, or Naya water versus crystalline water. I don't know if that still exists. So why do these products, why do we say they're elastic? Well, we say they're elastic because they look a lot like each other. So for instance, if Coca-Cola decides not to sell a kind of Coke, I have no idea what the price is, but imagine it's $1.50 and Pepsi is exactly the same price. And now Coca-Cola says, oh, now I'm going to sell my can of Coke at $3, so I'm going to double my price. What are people going to do, you think?
They're gonna change to Pepsi.
Yes, they're going to react a lot. Why? Because they have an easily accessible, perfectly good substitute. Well, some people say that they can taste the difference between Pepsi and Coca-Cola. I once tried and I failed. So I had one chance over two to have the right answer, and still I couldn't guess. So if you maybe you like the ads of one more than the other, I don't know, but they're mostly the same. Same thing with Naya water versus crystalline water. It's the same product, and if one becomes much more expensive, then you don't have to stick with it. You can change it. So that's what we see that that's what we mean by elastic products. So with that in mind, do you have ideas of inelastic products?
Fuel.
Cameras.
Cameras.
High-end cameras, like ones where it's not just like they're all the same.
Okay. Yeah.
I mean, I only say
At
that
that point, you're talking more about lenses.
No.
Yeah. So you could have that.
Like, can I give an example?
Yeah, go ahead.
Okay, so like with the chip shortage right now, Canon had to raise their prices for some of their high-end cameras. So they raised them by $300-400 in Canada and the US, and nobody cared. They're still buying them, and they're still selling.
All right. Okay, it's
Can we
perfect
use the
example.
smartphone? Can we use the smartphone market? Like people still buy Apple even though it's overpriced.
Yeah, but as long as what he's saying is true, that people still buy the super expensive cameras at the outrageous price, then it's true. But yeah,
I only know that because I work at a camera store. So
yeah, but for me and you, perhaps we're not professional photographers. So in our case, yes, the phone is perfectly fine. So as long as people still buy them. One example I've given last time was life-saving drugs. By the way, I've said, Martin Shkreli is a genius to raise the price of the drug 10 times. I really don't want you to think that I'm serious, that it's so awesome that he did that. I think it's awful. Yeah, so if you raise the price of a life-saving drug, then if I don't want to die, then I'm still going to buy it. So that in that case, we see that it's like I don't have a string on my behavior. I have a elastic. I have a string. I don't have any choice. Sorry.
Does fuel would be inelastic, or because when you go to even if the price goes up, you still need to put fuel in your car?
So what example?
Like gasoline, when you have to put in your car your fuel. So.
Yeah, gasoline. If you need your car to go somewhere and it uses some sort of fuel, then yeah, you're stuck buying it. That's why they always manipulate us and they change the price and we're stuck with it. But I'm going to add something. So imagine that. So you absolutely need to use your car every day to go to your work. And then the gasoline price goes up. So what are you going to do? You're still going to go and fill in your tank. You don't have any choice. But if you think that this price hike is going to stay forever, is there something you might do in the future?
Yes, choose alternatives.
Buy a bike.
Change the type of car?
Yes. So this would be gasoline. Yes. In the short run. Or in the short term. And gasoline in the long term. Not so much.
is that because the direct replacement for it to be elastic is like electric cars?
Yes, but it's everything. So everything in the short run is less elastic. because I didn't have the time to react to events. So something happens in my life, but I have the things I have to do. I don't have time to go buy a new car this week, so I just stick with this car. But if I can plan ahead, then everything is less inelastic in the future, or more elastic in the future, because I can react to things. So that's true for any good, and it's going to be true for the demand and for the supply as well.
I will say all the necessities and all that necessitate like the medical treatments and all the stuff.
Yeah, medical treatment. Food. So, but the thing is, food, you can still sort of survive on less food or on cheaper food, but you have to eat. That sort of thing. Right. So this, yeah.
So if I understand correctly, for there to be an elastic reaction, there has to be a direct replacement. Otherwise, there will not be an elastic reaction.
Yes. Yeah, I think that's right. So it's, I don't know. So you could think of something like, oh, I was planning to go on a trip to I don't know, to Europe. And then the airline prices went up, and I thought, oh, I'm not going to go there. So what am I going to do with my money? Well, maybe I just keep it in my bank account, go on vacation next year, or have another vacation. So in that sense, is not going on vacation a substitute for a vacation? I don't know. It's just I have to be able to change my behavior. But it's true that if you have a direct substitute, like for Coca-Cola and Pepsi, then of course they're going to be elastic. That's for sure. All right, so this is what it looks like to have inelastic demand. Relative inelastic demand. Yeah, no, they are okay. I don't know. I think maybe they made a mistake there. So that's elastic demand. All right, so that's elastic demand. How do you know it's elastic? It's horizontal. If this is quantity and this is price, then it means that the quantity varies a lot. So the line here starts from a quantity of 0, goes to a very high quantity. And while doing this, the price doesn't change a lot. So that's how you know it's, so elastic will look like horizontal.
So if it's horizontal, it's elastic, and if it's vertical, it's inelastic.
Yeah, exactly. If you have quantity there and price here. So what happens? Well, I have some shift in the supply curve, and I'll just finish my sentence. So I have a shift in the supply curve. What happens to the equilibrium quantity and price? Well, the price didn't shift all that much, but the quantity shifted a lot. So that's because consumers, they don't want to pay more, and they have substitutes. So if suppliers, for some reason, want to charge a higher price, then they're just going to go and buy something else on another market. So the price that suppliers are able to get from the consumers here is they're not able to get a very good increased price. And if I had a situation like this, for instance, where the demand is completely flat almost, then you see that this shift in supply curve is all a shift in quantity and is almost zero change in price. So that's what we mean. Yeah, there was a question.
Yeah, I wanted to know, like, I don't understand for the elastic, you were talking about horizontal. Is it for the curve? Like, I don't understand.
So if I'm going to show you another one, and maybe it's going to be clearer. So then this is inelastic, so it looks vertical. Is it? Do you understand more? This is vertical, or yeah, steep, and this is quite flat.
Okay. In terms of price and quantity, you were explaining something I didn't catch it.
Yeah, so okay. If elastic demand a shift in supply will generate large shift in quantity demanded. And small shift in price. We see large shift from Q0 to Q1, but small shift from P0 to P1. All right, and then the reverse here. So if inelastic demand, then shifted supply would create a small shift in quantity demanded and a large shift in price. So you see here, it's, and this is, so the demand looks more vertical or steeper. So that's inelastic. So here, what this means is people don't have any choice. They need to buy this quantity or very close to it. Otherwise, they're stuck or they die or they can't go to work. So even if the price suppliers want to increase the price a lot, they're still going to buy almost the same quantity, and they're going to, to have to spend to buy it. So if here you could think of it as yeah, so this would be a Canon that makes its cameras, high-end cameras, much more expensive, and still people just agree to buy them at this much higher cost, and that's it.
I have a question. Does it only work if the prices increases? Does it work if the prices decreases as well? Like, I don't have an example in mind, but could it work?
Oh yeah, if you, so just put 0 to 1, 1 to 0. So if the supply was here, and then there's a, so say we get out of the pandemic, and Canon says, okay, now I'm going to go back down and sell my cameras at a lower price. But then it's not like there's so many more customers that are going to buy them. Anyways, all the consumers that were buying Canons were buying Canons. So they don't have such a large increase in their consumer base. Whereas in this example, if this was, I don't know, Coca-Cola, for instance, and not a lot of people were buying Coca-Cola, but then they lowered their price, and then all of a sudden, tons of people want to buy it. So everything works in both ways.
Sorry, sir, can you repeat for the inelastic, like when the price goes up, people have to buy the product.
So why don't you understand? It's this. So if the supply shifts to the left, then you have a small shift in quantity because people are not able to react all that much to it, and a large shift in price.
Okay.
And it looks very steep. All right. So now let me see how we compute the elasticity. So before we had slope. Slope is yeah. Slope is delta Q over delta P. Or yeah, rather it would be delta P over delta Q, but yeah, here it's delta Q over delta P. So if you were talking about Coca-Cola, then it's how many more bottles of Coca-Cola
Hello?
you would buy as a result of a change in the price. Could you have your phone call in?
Ben, je t'en cours en ce moment.
All right, so we're not going to hear this conversation. Yeah, so that was slope. So what's wrong with it? As I was telling you, so delta Q here would depend on how large the market is, or it would be specific to what goods we're talking about. But then elasticity, what it is, it's just instead of talking about units, we talk about percentage change. So what we say is how if the price increases by 1%, how many percent is the demand going to decrease, for instance? So, and how do we compute it? We compute it this way. So delta Q divided by Q divided. So this line should be longer than the other. Yeah, just to be clear. So it's this fraction divided by this fraction divided by delta P over P. Plus, I like to write it this way. So it would be equal to delta Q over delta P. Divided by, yeah, no, let's not do that. Times. So let's have this be larger. Okay. Then I can have some small bars there. It's not easy to do math on that program, but still it works. All right. So that's another way of writing it. You see that all I did is I kept the delta Q over delta P here, but then here I put the Q at the bottom and P, since it's divided and there's divided here too, so it means that it's multiplied by P, so it goes here. So this gets, so it's like the slope multiplied by P over Q. So it's exactly the same thing. If you understand it better this way, compute it this way. If you understand it better this way, compute it this way. And again, I'm going to, yeah, so percentage change in quantity demanded divided by percentage change in price. So it could be, for instance, minus 2% divided by 1%. So if the price increases by 1%, then the quantity that people will like to buy will decrease by 2%. This kind of thing. So the advantage of that, yeah, just finish. The advantage of this again is you don't have any units. Here is just percentage change. So it's the percentage cancel out, and you get just it's just equal to say -2. So that's very convenient to talk about. Yeah, go ahead with your question.
Sorry. Will we ever have to calculate the percentage?
I'm writing percentage, but really what you're going to have to calculate is these things there. So delta Q over Q, delta P over P. So yeah, you are going to have to calculate that.
Oh, wait. Oh, so that calculation, the Greek letter eta, right? That whole calculation will equal to the percentage. Or what?
Yeah, it's not exactly percentage. So yeah.
At the end of all this calculation, we'll get to a percentage.
No, you get to a certain number. This is just to, or this is how you think about it.
Is this where you get percentage points that you see in stock markets?
Okay, so yeah, it's not percentage points, it's percentage. Okay, yeah, sorry, I wanted to help you with this, but maybe it's more confusing than that. So maybe I can just remove it. So don't get scared about percentages. Just think, okay, I have to compute delta Q. I have to know Q. I have to compute delta P. I have to know P. So delta Q, you know, it's a change in quantity from one point to the other. Delta P is the same for price. And then you do this computation with this formula here or this formula, which are the same. And you get the number we are asking for is here, it's eta.
Sir,
Yes.
here Q and P are those the equilibrium price and quantity?
Okay, super important question. I'm very happy you asked that. So yes, it depends at what point. So I'm never going to ask you, oh, what is the elasticity of Coca-Cola? I'm going to ask you something like, what is elasticity of Coca-Cola at this quantity, for instance, or at this price, or usually it's at the equilibrium. So if the equilibrium price is $5, then and the equilibrium quantity is 500, then I'm going to say at $5, 500, what is the elasticity? So what will happen if there was some change in the quantity or price? Yeah, that's what I'm going to ask.
Are we ever going to use the middle point in this course?
What do you mean by middle point?
It was the same formula, but you add the two quantities and you divide by 2. If it's between a variation between 2 points, you add the lower and the higher and you divide by 2.
I think so. yeah. I've watched what's going to happen, and yes, that's what I see. So usually what they're going to say here, since delta Q may be large, so what they're going to say is delta Q is Q start is Q at the end minus Q at the start, and then Q is an average of the two things.
Okay, thank you.
Yes.
Is there unit elasticity? Like, is there unit?
Yes, that's the beauty of it. It's that there's no units. So if I wanted to say what the units would be, so for instance, so this is, if it's confusing to you, don't pay attention to it. But yes, it's something. It's a nice point about it. So about units, elasticity has no unit. So that's why we are able to compare the elasticity of Coca-Cola with the elasticity of medication, for instance, because it has no unit. And let me show you why. So you would have something like delta Q would be, I don't know, units, like yeah, bottles, if it's Coca-Cola, for instance. And delta P would be dollars. And here price is dollars. And Q is bottles. So you see that bottle cancel with bottle, dollar cancels with dollar. So in the end, you get no unit at all. But so this, don't pay attention to it if it confuses you, but it's just to show you how the units disappear. Price cancels with price, Q cancels with Q.
Sir?
Yes.
I don't understand one thing. What's the how is percentage related to this problem? This formula.
Yeah.
Is it like the first part of the fraction?
Yeah, so delta Q divided by Q, if
Q is the percentage.
so, yeah, so what you would have is, for instance, if the Q is 100 and delta Q is 2, and then P is 100, for instance, and delta P is 1, for instance. Then you would say that delta Q over Q would be 2 divided by 100, so it would be like 2% divided by delta P over P, which would be here 1%, for instance.
Okay.
But I picked 100 there, and you know, it's not it's somehow percentage. It's the way you can think about it. But you know, we're talking even about smaller changes than percentage. So yeah.
So you picked 100, so you can make it easy for you to calculate percentage.
Yeah.
And is the average from 0 to 100? Like, is the average from 0 to the point you picked?
No, that it would be so it would be Q0. Yeah. Okay, so it would be Q0 equals 99, and then Q1 equals 101. Okay, so the average of that would be Q equals 100. So the average of 101 and 99. Same thing for price, for instance.
Did it say the average is 2? When it's delta Q?
Yeah, but delta Q is 101 minus 99, which would be 2. So anyways, I have to move on, and we're going to see an example in which it's, you know, it's, you see the curve and you see what you have to calculate. Okay, so let me remove this. All right. So the demand has a negative slope. So the percentage change in price and quantity have opposite signs. So this doesn't change. But when we say that something has a small elasticity or big elasticity, we mean in absolute terms or in size. So if something has a elasticity of, say, demand elasticity, I don't know, what is my eta sign? Yeah, eta is minus 100, for instance. We say it's large in absolute terms. Yeah, again, because people don't like paying for stuff. So when you increase the price, quantity demanded decreases. So the elasticity would be negative. But if it's a very, very large negative number, like minus 100, we say it's a large elasticity. We don't say it's a super negative elasticity. It's just a way to talk about it. That makes it easier for us.
Sure. Here you wrote that the elasticity is minus 100, but like in an exam, would we write just 100 because we report the positive number?
Thing is, I haven't done all the MyLab examples, so I don't know how MyLab asks you to to answer them. But yeah, normally we would say something like, yeah, the definition of elasticity would give you eta equals minus 100, and then you would say the absolute elasticity is this, which would be equal to 100, to be exactly precise. All right. So here it is. Here's how they compute it. Yeah, so it looks like they always use the center point between the two. Yeah, I don't know. Let me compute to see if that's the center point.
So in this case, we can use it's called the other formula, where we can multiply the equilibrium times the slope.
Yes, the other the slope times the equilibrium is the same thing. So yes, they always use okay. So this you have to know where. Oh yeah, they use average quantity exactly, and average price. Okay, yeah, it's written there. It's just I checked on my side to make sure that this was the average. So yeah, let me just rewrite this in another way. So eta would be equal to so yeah, new price minus old price divided by new quantity minus old quantity. And then multiplied by new price plus old price divided by 2 divided by new quantity
Sir,
plus old quantity divided by 2.
sir, these are going to be on Moodle. Do you have like the notes here?
Yes.
Sir, is what you're showing just an alternative way of doing it?
Yeah, I'm just to tell you exactly where these numbers come from.
Okay.
If you just have new and old, then how you compute it is, I'm just showing you the average there.
Sorry. It's just because I feel more comfortable doing like the way on the left.
Oh
the
yeah,
way, like that's in the notes, so we could do these like we have a choice. We're gonna get the same answer, right?
Oh yeah, sure. Yeah, I'm not. I wouldn't lie to you. I wouldn't show you something that's wrong. So yes, it will give you exactly the same. Yeah.
Okay. Thank you.
All right. So
I think is that. Oh no, this is wrong. Sorry. Yeah, this is
we have got the original price and also the average. I'm confused.
Yeah.
We have got the original price and the original quantity. So, like, why are you dividing by 2? I don't understand.
All right, so that's the real thing.
So wouldn't it be new minus old divided by old, and then over new minus old divided by old?
No. Yeah, that's what I would think too. But here they want you to use the average point. So I think since they always write it this way, that's how you're going to have to write it. Okay, let me put that down here. It's easier. This thing there.
Sure, I have a question.
Yeah, go ahead.
You see new price minus the original price. Shouldn't it be inverse 3 minus 5?
Okay, where are you? Where
It
are
should be
you?
new price minus old price. So
New
it should be
price minus
3 minus
old
5. I
price.
mean.
Okay, I'm going to move my mouse and you tell me where you think there's an error. Here?
It's just in the example up on the top.
In the example.
You wrote 5 minus 3.
Okay,
It should
so
be
I
vice
didn't try
versa.
it. Average new price. Old price. Original price.
Can you write
Yeah,
down?
it's 3 minus 5. Yeah. Oh, geez.
I think it's because of like
Can you-
what
can
it
you
said in
write
the
the-
slide before. It says that it's always a positive number, so maybe that's why they.
Oh yeah, but no,
arrange it in that way.
you shouldn't think that way. So you should think in terms of change. So here there's a change for sure. Okay, so I have my way of teaching things, and then they have their way of presenting things. You're going to face examples that are given by them on my lab. So now I have this conundrum. Are they going to want you to? Anyways, okay. Yeah, this is, let me go back to their formula here. So if we think that this is their formula, eta is delta Q over Q divided by delta P over P, then delta P is new price minus old price. Okay, so if I take this, then new price is 3 minus old price 5. So yes, let's change that. I'm going to ask the other teachers about this because this seems quite weird to me. So it's 3 minus 5.
Wouldn't that make the rest of the equation negative?
Yes, That's the thing. It's the demand elasticity is negative.
Okay.
So my guess is they made a mistake when they made this, and this should be $4 because we keep the units. Yeah, and you see that anyways, dollar, everything cancels out. So here you would get 3 minus 5, so that would be -2 in front of that. Yeah, so you would get minus this, and you would get minus 0. And then if you were to ask what is in absolute value the elasticity, so it would be eta in absolute value would be equal to absolute value minus 0.125. Absolute value equals 0.125. Okay, I am really going to have a conversation about this so that I can come back to you and tell you, okay, this is exactly how things are working. Because, yeah, delta P is here. If you have new price is this and old price is this, then the change is 3 minus 5, so it's minus $2. There's no question about this. Oh, and here there's a minus sign.
Sir, I don't understand the calculations here. Because if it's divided by 4, it's supposed to be
it's divided by average price.
Yes, but like that means the end answer is not 0.125.
Are you sure about that?
Because
okay, so 3 minus 5 is minus 2 divided by 4. Minus 2 divided by 4 is 0.5.
Let me check. Because I didn't. Yeah, I don't think so.
Yeah, 0.06 multiplied by 2. So divided by 1/2 is like multiplied by 2. So 0.06 multiplied by 2 is like 0.12.
Okay, I got
6 times 2 is
0.5.
12.
It's
good to always be skeptical of calculation and do them yourself.
Wait, I don't know. I got negative 0.5. Wait, so I'm supposed to. Oh, wait, never mind. I think, yeah, I understand my mistake.
All right.
Yep.
Okay. All right. So elasticity along a linear demand curve. And this is going to be make clear how this formulation is nice, or this formulation there. Let me just copy it. Because if you use this formulation there, no, that's this. It divides. So you can see why it's very simple to, so here, this goes back to the question of what should I use as starting point for my elasticity? Yes, you have to ask yourself that question because it's not always the same. Here, the elasticity is one thing. Here, the elasticity is one other thing. And here, it's, again, one other thing. And how can you know which side is going to be larger? Can somebody tell me right away? Well, you can kind of read it, but is the elasticity going to be larger here or here?
It's larger at AB.
Yes, exactly. And if you use this formula, it's super simple. Because why? Because it's linear demand curve. So delta Q divided by delta P is always the same, is constant. So it's the same here, same here, same here, same here. The only thing that's different is the relative value of price and quantity. So you just have to look at this expression and ask yourself, in this region, how is P divided by Q? Well, the price is very high, it's 11 or 12, and the quantity Q is very low, it's only 5. So the elasticity is large. And here, on the other hand, yeah, here the price is very low and the quantity is very large. So Q is large, P is small, so elasticity is going to be small.
I have a question. Is it possible to have elasticity along a curve that's not linear? Or is it only for like budget ones?
It's only for if you do a PhD in economics. No, I'm kidding. We're going to see it in the next example.
Sir?
Okay.
Yes.
Is it possible that the elasticity is 0?
Yeah, that in which case do you think?
Is the slope of the line going to be 0 as well?
Yes, so the slope here, if the slope is 0 or so exactly 0, I would be surprised, but super small, it's possible. If delta Q over delta P is very small, then yes. So if you have something that's extremely inelastic, then it means that the elasticity is extremely small. That's what it means, extremely inelastic, so very small elasticity. So that would be, say, a demand curve that would be almost vertical. So yeah, you're absolutely right.
Oh, it would be vertical, not horizontal.
Yeah, the thing is, so it's delta Q over delta P, but here we have P and Q. So you see, it's the same issue we had previously. People were confused. Yeah, why do you have Q as function of P, but then you show P as function of Q? So yeah, that's because of Alfred Marshall. We put price on the vertical axis.
Okay.
So don't get confused. So always look carefully at the formula you're using, so as to not get confused when you're looking at the graph.
Okay,
this is it's a big source of confusion for me when I was a student, and for many students. We're not used to that.
I have a question. I understand where they take the number for the delta Q and delta P, but for the P and the Q, is it in the middle or the?
Yeah. So personally, I wouldn't use the middle point. I would use the starting point, but I think they want you to use the middle point all the time. So use the middle point. Yeah. So
okay.
P and Q. Use the middle point. By the way, so it's just because we're dealing with delta Q and delta P, but as soon as you learn how to use derivative, then you don't have any problem because derivatives are very, very tiny changes. So you don't have to worry about starting point, ending point. It's everything goes away. So when it's really a tool that once you use it, it makes your life so much easier. Right, questions?
Yes, I have a question, sir.
Yeah.
So I got confused when you were explaining about the elasticity, whether it's large or small. Like we can see with the numbers of the unit of the slope, so n. But I don't really understand what you were explaining, like in terms of quantity and price.
Well, it's all I'm saying is if you have so you're talking about this graph here.
Yes.
So all I'm saying is if you have a linear demand, linear means that the slope is always the same. It looks like a line. So in that case, delta Q over delta P, it's the slope. It's the same value at every point. So it doesn't change. So then there's only one thing that changes along this line, and it's the relative value of P and Q. Here, price is high and Q is small. So P over Q is large. So the elasticity is large. And here, P over Q is small. So the elasticity is small. Always in absolute terms, right? Because it's always, this thing is always negative because delta Q over delta P is always negative. But in absolute value, in magnitude, it's small here and it's large here.
Oh, okay. So you're talking about n. So the value of n in terms of the value, absolute value.
Yeah.
Once it's a big number, then that means that the elasticity is large, right?
Yes. You understand perfectly.
Okay. All right. Thanks.
Okay. So let me see if I can have one last slide. Oh yeah. So question: what happens if it's perfectly inelastic? Well, it's vertical, and in that case, the elasticity is 0. The opposite, if it's perfectly elastic, meaning it's horizontal, in that case, the elasticity is infinite. So these are extreme numbers. And we have also a special case here, which is unit elasticity. And in that case, it just so happens that if you have this shape, then the slope will compensate exactly for the relative value of price and quantity, such that when you compute eta, it always has the same value. So yeah, here I would, okay, here they write, yeah, they continue to write it as it's, if it was positive. Yeah, I'm surprised by this. Because here what they would have had to do is put that in absolute terms. So in that case, it would have been the case. Because here what you would really have to write is a negative sign here and a negative sign here. So, all right, let me stick with the slides I have. I'm going to ask my colleagues about this. Yeah.
Or what do you mean by finding the middle point? How do you do that?
Oh, if you have, so let me go back to here. So the thing is, so I have a new new quantity, 123,000 minus old quantity, 116,000. But then do I divide by 123,000, 116,000, or something in between? And it looks like they say what you have to do is use something in between. Yeah, so you use the average of these two terms. So the average is 120,000.
Okay, thank you.
Yeah. Okay, what time is it now? Yeah, 10:01. Okay, so yeah, we're out of time. So let's continue this here next time.
Sir?
Yeah.
Thank you. Goodbye, Professor.
I had a few questions about the second chapter.
Yeah.
Yeah, I'm just gonna pull up my book. Could you explain what the increasing marginal production cost is all about?
So you mean what do we mean by this?
Like the marginal cost.
So what we're saying is, so the best way to imagine it is, imagine I'm a self-entrepreneur at home. So I produce shoes, for instance. So I make them by hand. So what's my cost of making like 3 pairs of shoes per day? Well, it might not be so high. So it's okay. It takes me 6 hours and I'm done. But then if you want me to produce 10 pairs of shoes, then then I have to work until late at night, and maybe I have to make a lot of sacrifice to make this. And if you ask me to produce 12 pairs of shoes, then I have to work 22 hours over 24. So it's almost impossible. So you see what this means is it gets more and more difficult if you don't have the resources to increase indefinitely the production.
Or are you talking like manpower or like in supply?
So that's in any domain. But the thing is, so in modern economies, you can have many different sorts of cost structures. So for instance, if you're Google, what's the extra cost of one extra user of Gmail, for instance? Well, it's zero, because everything was programmed already, and for them to have an extra Gmail account is nothing. So in their case, you wouldn't say that they have increasing marginal costs. But so increasing marginal costs is really relevant for small business, for instance, or a place in which you don't have all that many resources to work with. Or if I'm a farmer, for instance, then you ask me to produce like 1 ton of cucumbers, so I can do it easily using my field. But then 2 tons, I would have to add a lot of fertilizer and work very long hours to make sure that I plant them correctly. And you see, it's more and more complicated for me to work my field.
All right. If we are in a usine environment, when you buy stuff in bulk, it's usually less expensive by the unit. That's why I was confused.
Yes, so things don't have to always have increasing marginal costs. So it depends on the situation. And so in general, we can observe that in many situations, but not always. As you're saying, it can be the case that if you have a larger production volume, then actually your marginal cost is lower.
Oh, thank you. There's also another thing. Like, I'm just gonna read what it's written in the book because I got confused by that too. The marginal response of a variable gives the amount it changes to response to a change in a second variable. I don't understand.
A small change in a second variable. Yeah, so for instance, if we talk about price and quantity supplied, so what would be the marginal response in the quantity supplied when there's a small change in price? So if the market price changes from 4 to 4.1, then what would be the market quantity supplied by producers? It would change from 10 tons to 10.2 tons, for instance. So that's what marginal means. At the margin means a small change. Is it clearer, or are you familiar with math? Can I use a formula?
Yes.
Or
yes.
Okay.
I would rather have the formula.
Yeah. So it's just the derivative, basically. So let me.
The derivative of what?
Yeah. So it's so okay. I'm going to share my screen. Yeah. So if I have quantity produced or cost, let's go with costs. Costs equals 10 plus 2 times quantity produced. So then what is the marginal cost? Is equal to just 2. It's the derivative. It's the cost divided by the quantity. So it's equal to.
So the variable is the quantity produced.
Yeah.
Okay, so if in an exam they ask me for the marginal cost of something and I have the formula for the cost, I can just take the derivative and it's gonna give me the answer.
Yes, but I think in this class they're not going to ask that because so many students are unfamiliar with derivatives. But yeah, for me it's a pain to teach economics without using derivatives. I believe me. But yeah, that's what it says. So marginal cost is delta. It's the cost over the quantity.
Okay, I'm just gonna note that real quick.
Yeah, it's sometimes if people have really no knowledge of math, then you have to use lots of words to express something. But if somebody has too much knowledge of math, then they get more confused. Whereas you just pull out the formula and it's just, yeah, it's right there. That's the exact definition.
I also like I'm trying to read the book at the same time as following the class schedule, but I got behind. Like right now I'm still on chapter 3 and we're close to finishing chapter 4. Do you have any idea how I could like catch up easily?
Oh, all right. So, well, of course you spend more time reading it, but so how I would, so I can tell you what I did while I was a student.
Mm-hmm.
So your job as a student is, of course, the job we say it should be is to learn stuff. But immediately what it is really, we are not kidding ourselves, is to have a good grade, and that's it. So how do you manage that? Well, you have to think what should I do to learn as quickly as possible? Because you have many classes and many things, so you have to spend as little time as possible on learning as quickly as possible. So maybe using the book is good and reading all of it, or maybe not. In my case, I realized that usually I use the slides, and then sometimes I'm not too sure about one concept in particular, and I'm like, oh, what are they saying there? Then I go and look at the book, and I read the passage about this topic, and oh, now I understand what they mean. But otherwise, if you think it's too long, then you don't read it, of course.
Yeah, like every chapter is around 50, 60 pages.
Yeah, it's super verbose, and yeah, especially if you're good at math. So believe me, so all what we're learning right now, when I was teaching it in Europe, in Rennes, I would spend 3 hours on it, on the like almost like half of this whole course. I spent 3 hours and I was done. Few equations and that's it. Yeah, but you know, they were quite good at math, so it helped a lot.
Okay. Do you know how long are the two first labs?
The two first what?
Labs on.
Oh, the labs. How long they are? Well, it's a few questions, but so yeah, it's a lot of questions, but each question doesn't ask you for a lot of calculation. So yeah, I would definitely encourage you to do them as quickly as possible. And yeah, so that's what I'm saying. So when students think, oh, I'm just going to do tons of exercises 2 days before the exam and I'm going to be good, then they're right. I mean, the way to have a good grade is to become fast and very familiar with the type of questions that they're asking. So for you to do well, what you should do is go to the sections where on MyLab where they have tons of practice questions. Do all of them as best as you can, and then do the labs, and they look exactly the same. Okay. So yeah, and by the way, the lab, don't get too scared about it. It's just a few percentage points under your final grade. It's really to make sure that you learn how to answer exam questions quickly. It's there to help you. Yeah.
And from what I understand, the questions are really like common sense based. Like there's like a little story, I guess, like about farmer with some quantity and the price, and you just have to change stuff in the graph.
Yeah, exactly. Okay. Yeah, so that's why what I'm saying too is, if you just read the whole book and think, oh, should I learn that by heart? No, look at what the type of questions they're asking you. If you think they're easy, then stop, just work on your other classes, and you think, oh, that's in the bag, I don't have to worry about it. So yeah, so learn to prioritize, and don't read too long if it's not helpful.
All right, thank you so much, Professor.
My pleasure. Other question? Yeah.
For the elasticity, the star before the price, like, can you just go back to the formulas, please, just quickly?
Yeah. So you tell me when you're happy where I am, here or here, here?
Yeah, here.
Yeah.
For the stars, the star before the P, the price.
Oh, that's multiplied.
Yeah, okay, perfect. I was a bit confused. Thank you.
I cannot select it for some reason.
So it's like the variation of the quantity and the price multiplied by the.
The price divided by the quantity. Yes.
Perfect. Thank you.
Other question? Okay, then have a good day, everybody, and see you next week.
Bye.
Bye.
Bye, sir.
Thank you, sir. Have a good day.